Like you said, my name is Paul. I've been a cloud engineer for a few years now. I've been in the space for about 10 years. So a little bit about me. So I'm a cloud engineer at Beckman Coulter. I've been working in or around the space for about 10 years. I was actually introduced to cloud technologies by way of automation engineering. So I originally came in through kind of QA software development. And from there, I kind of transitioned into DevOps, the DevOps space. It was a pretty organic transition, actually. At the time, which was circa 2012, 2013, there wasn't really an established DevOps team in a lot of companies. So basically, automation engineers filled that role just as an organic by virtue of what they were doing. So that's kind of how I got into the space. But I've definitely been loving it. I graduated with an MS in software engineering here in 2019. So I'm a proud alum. Hopefully, I inspire confidence in the program. And if not, I went to Cal State Long Beach. So I guess I was going to start off with kind of a story, a DevOps debugging story. And this is kind of a way to give you an insight into what I do and kind of challenges I face. So this is a somewhat crude diagram that I put together where basically this represents what I was staring at on a Saturday afternoon, roughly, it was a year ago, 2 years ago. So at the time, I was new to a company that sold medical devices. And the company at the time was kind of in a cloud transition period. So they had a lot of on-premise servers. They were transitioning to the cloud and furthermore to serverless in the cloud. And on a Saturday morning, we got paged, me and the other SRE, site reliability engineer, and we were told, hey, the orders aren't coming through. And so this was a company that basically shipped medical devices. So the customers were medical offices, essentially. And we would fabricate the devices and then ship them to the customers. And so the warehouse called us, said, hey, something's wrong, you need to take a look at it. So we took a look at it and we started just debugging. Between the two of us, we probably had about 3 months of experience on the team. So it was like the two stooges trying to go through the debugging process, basically. But we started here at the top. So the user submits the order. This would be basically the medical office. They submit that order to an AWS API gateway, which sends it to the modern service being the service that displaced the legacy service. From there, it goes to RDS. RDS sent it to a Lambda function, and the Lambda function then sent it to the legacy service, which we were maintaining for basically business requirement purposes. The legacy service would then write it to an S3 bucket, which had a Lambda trigger, which sent it to a Lambda, which would then write it to the packing list, send it to the warehouse, and then ultimately off to the happy customer. So that was the kind of the high level overview of what it looked like. So of course we started at the beginning, which was just trying to peel back the layers. So we said, okay, why isn't it getting to the packing list? We looked at this Lambda looked good. We saw activity in this S3 bucket, and we basically went backwards and backwards and backwards. And fast forward 5 hours later, an engineer realized that this Lambda, even though it existed, it hadn't been invoked in roughly 12 hours, which is anomalous because it should get invoked roughly every hour. And so from there, we actually looked at what the trigger was. And it turns out the trigger for this Lambda function, you guys see my mouse, right? Yeah. The trigger for this Lambda function is this S3 bucket. So there's basically a trigger on this S3 bucket. Whenever anything goes into the S3 bucket, it triggers a Lambda function. But we had a vendor about 24 hours earlier who was doing a demo, and allegedly their demo wasn't going to do anything destructive. But what it did was it wrote another trigger to that S3 bucket, this S3 bucket. And it turns out AWS only supports one trigger per AWS bucket. So they effectively displaced our trigger, which is what caused the backup. And so we're now about 6 hours into the outage. We figured it out, and we were able to resolve it by basically recreating this trigger on this M-3 bucket. So this is kind of the wild world of DevOps, obviously. And I highlight this story for a couple of reasons. Number one, it kind of highlights the multi-tech stack nature of a lot of what we were doing, and how some of it was legacy code, some of it was new code in this modern service, some of it was RDS databases, some of it was serverless functions, And so jumping around the stack turns out to be pretty cognitively taxing. And so that's kind of, I think, a good way to frame a lot of what I'm going to be talking about subsequently. It's also a good story because it highlights the importance of infrastructure as code, which is another practice that we were trying to implement at the time. So the problem with an architecture like this is if you don't have infrastructure as code, it's not obvious what things are triggering what other things. And so it becomes a matter of understanding tribal knowledge in order to figure out what's invoking what, because there's unknown unknowns and you don't know what's invoking this Lambda. It could be a trigger. It could be somebody calling it by hitting an endpoint. It could be another Lambda calling it. It could be an RDS trigger. And so in the absence of infrastructure as code, we can't audit the changes. We can't see when the last changes were made, which is what we did with the actual application code. Obviously, that's kind of what you do. You look at the GitHub commits, you say, when was the last release? And that's actually what hung us up for about an hour and a half, looking at all the old last release, which didn't quite align. And so infrastructure as code ended up being one of our main mantras going forward, because we wanted a way to be able to audit what had changed. So like I said, that's a good way to kind of frame the discussion that we'll be having. And my goals are really to demystify DevOps. I think DevOps is now fairly well known in the space. It's not likely that any of you guys are completely unfamiliar with it, but what mystery does remain, I'd like to dispel here. Share learnings, like I just did, in terms of things to look out for, and then also just spark interest in anyone who's interested in taking their career in that direction. A lot of this will be obvious to you guys probably, but some of it might not be. So I'm hoping that you have enough, take away enough to at least justify the talk. How many of you guys have worked in DevOps before or in DevOps adjacent spaces? Okay, cool. Are you guys DevOps engineers?
Not like little bit of DevOps and little bit of DevOps, like software plus, because your system is quite large, but in mid-scale systems, we don't break it down that much. Maybe 2 or 3 steps.
I see. Yeah, you see a lot of that. I think development has really demanded that you know at least a little bit of DevOps. And so I think this will be applicable to anybody, even if you're not in DevOps. I think a lot of these paradigms are going to define the industry moving forward. So that being said, the first topic I wanted to bring up was DevOps versus site reliability engineering versus cloud engineering versus infrastructure engineering. There's obviously a lot of terms out there, and it's kind of an overloaded space in terms of how people use to, the words people use to describe the different services. So kind of starting off with DevOps, I think that's the natural place to start, right? So DevOps is really more of a philosophy. I've never been big on policing words and saying, oh, this phrase only means this and should only be used for this. But purists in the industry will insist that DevOps is not a job role, it's not a job function, it's a philosophy that basically involves certain key tenets in terms of culture, automation, measurement, and sharing. And so I'll kind of go over what those mean in the context of DevOps. But just to kind of set the table stakes, DevOps is not formally a job function. It's more of a philosophy. So in terms of the principles, like I said, culture is crucial. So DevOps really kind of dovetails on a lot of the Scrum principles. You know, with Scrum and Agile, a lot of the focus is people-oriented. So they always say people are key, people are focused. DevOps kind of takes that same philosophy and applies it to the operation space. So people are the center of development operations. And as such, we want the culture to kind of reflect what they're doing, right? So culture is always super crucial. And it's always important to remember that the tools are really secondary to the culture. Tools enforce the culture. And it's very easy to forget that, even myself, in a space that's full of so many shiny new tools all the time, right? So the other thing is automation drives process. I think the industry was a bit overzealous with the push towards automation of roughly 5-7 years ago. Automation is obviously key, and we obviously do want to automate everything. But I think at a certain point, people began to try to take humans out of the loop. The idea was humans are error prone, right? So we want to basically take them out of the loop so that there's no errors in the system. Turns out that doesn't really work so well because humans also create the code. And also, if you just look at the law of entropy, if you leave a script running, let's say a CI/CD script, you set it up, leave it running for the course of 3 months, 4 months, it's not going to just run perfectly indefinitely. If it invokes, let's say, Chrome browser tests, those browser tests are prone to break because Chrome updates. If the code changes, some of the integration tests might fail. So we have to keep humans in the loop. With that being said, we do want the automation to basically take as much of the manual process out of the loop as possible. Measurement. So measurement is another key to DevOps. That's the M in CAMS. So metrics really should be guiding our analysis, and they should help us objectively drive towards a specific goal. Specifically, we want to know, are we using the right metrics, and are we using the metrics that incentivize the right behavior, right? So it's very common, obviously, in the industry to have like Jira tickets or some sort of ticketing system where you assign points to tickets, and if you want to increase your velocity, you can just inflate the ticket points, right? That's a way to hack the system, or just create really minor, tickets for everything you're doing. We want to make sure that the measurement tools are actually incentivizing the right behavior. So I think that's key. Then also sharing. So traditionally, DevOps attempts to break the silo between development and operations, hence the name. I think silos maybe get too much of a bad rap because naturally silos are going to emerge in any big industry or in any big company, right? As a developer, I shouldn't be talking to the React guy and the networking guy and the DevOps guy and the infrastructure guy on a daily basis. We do want some level of siloed autonomy, but I think the key is creating the interfaces between the departments and between the individuals that's really going to support the most natural. So much of DevOps work is going to be aimed at eliminating toil. That's kind of what I'm driving at. So the DevOps motto is really going to be that we want to make tomorrow better than today. So that was famously stated by, I believe, Gene Kim, it's a famous DevOps advocate, a researcher, kind of trailblazer. And DevOps, as I'm sure you guys know, has roots in the manufacturing process improvement movement, actually. So, the famed Toyota production system is basically a manufacturing line in Japan, where they've really gotten the art of manufacturing down to science. And a lot of DevOps practices are really taken from that and designed to mimic that in a way that took a lot of learnings from the manufacturing industry and kind of projected them onto the DevOps and application operation space. There's an annual state of DevOps report that tracks and explains a lot of the practices that are emerging in DevOps. If you guys are ever really bored or you can't sleep, you might try reading that. It's kind of dry, but it's good fodder for interview conversation, if nothing else, when you're interviewing. So some of the key findings that Gene Kim produced, Gene Kim is that person that I attributed the quote to a couple minutes back. So he looked at elite organizations, elite performing organizations in the tech industry, elite as measured by their security posture, by their deployment frequency, and by their success rate in terms of code deployment. And he found some pretty interesting things compared to their contemporaries. They do deploy 46 times more frequently. They have a 2,555 time faster lead time for shipping code. So they're basically able to ship code very quickly from the developer workstation to production. They are much faster to recover from incidents, and they have a 7-time lower failure rate. So obviously, these things really drive a lot of their high performance. And what's cool is these dimensions that I named really merged somewhat atheoretically, meaning it's not like he took this framework and used it to analyze the teams. What he did is he looked at what kind of things were common among the high performers. And so it's kind of a natural statistical emergence of these 4 factors: deployment frequency, lead time, recovery, and change failure rate. So that's pretty compelling to keep in mind, I think. So that's DevOps in a nutshell at a high level. So in terms of drilling down to the actual job applications or the job roles or functions, so site reliability engineering is an implementation of DevOps. So it obviously, as the name suggests, it focuses on reliability, observability, and alerting. The idea being that availability is the most important attribute of a system, because you can have a fast system, you can have a secure system, but if it's not available, it's really not going to do any good. So that's kind of the principle behind site reliability engineering. One thing is it really emphasizes coding. So it emphasizes really taking application practices and using them in the context of development operations. So Google really blazed the trail in a lot of this. I believe they came up with this job title. I think it was in like 2003. And they created a book called Site Reliability Engineering that outlines a number of tenets that they deem as being crucial to site reliability engineering. One being creating code and making sure that your code is, making sure that the SREs are always writing code. The idea, again, being to drive down toil. The way that you reduce toil is to automate things. You automate things through code. So that's the philosophy there. It's highly involved in reliability processes as well. So this is pretty interesting because in the two roles where I was a site reliability engineer, we really drove a lot of the process around remediation, around postmortems. So when the site would go down, we would actually write the write-up to show what happened. So there was a fair amount of administration involved as it related to communicating and remediating the issues. And that's slightly different from the dynamic, I think, that other DevOps roles play. Because usually, as a DevOps engineer, you're deferring to the project manager or the product person, basically, the Scrum Master, the person who works in that space. But as an SRE, I think you should expect to do a lot of the administration work and handle a lot of the administration overhead as it relates to the remediation process and the improvement process. So you're gonna do escalating, creating communication channels, postmortems, like I said. Yeah, Google came out with that book that I mentioned. Some other key things, and these terms aren't necessarily specific, I think, to SRE, although I think they may have emerged from Google in the early 2000s around this. But I'm sure you guys have heard of SLI, SLO, and SLA. SLI is service level indicator. So that's what you're going to use it's the components or the measurements that you're going to use to determine if your website is healthy. So things like uptime, response time, just depending on what you're measuring, that's going to be the metric that you use. SLO is service level objective. So as a department that you say, we want 99.9% of uptime. That's our SLO. That's our objective as a department. And you have SLA, and that's the actual agreement that you make with other teams. So service level agreement, you want to make sure you never breach. So typically you buffer the SLO and the SLA. So if your SLO is 99.9% uptime, you might only tell tell the teams 99% of uptime to give yourself that that 0.5% buffer. Another thing that they outline in that book called Site Reliability Engineering is error budgets. And again, I don't think this is specific to SRE work, but it's pretty central in terms of the way that they measure things. So basically the way the math works is 1 minus your service level objective is your error budget. So if your uptime desire is 99.9% uptime, then that gives you 0.5% downtime, obviously. And so any updates that you make, any migrations, all have to, when you aggregate them, they can't exceed that error budget. And that's the way to be able to actually make updates while maintaining your SLA and SLO. And in terms of organization, typically the way I've worked is I either have a standalone department in which we're all SREs kind of interfacing with one another, or there's the embedded model where we're essentially embedded on product teams. So we might be on the mobile apps team and helping them, and then we might be moved in a month to another team. And then there's squads and guilds, which is kind of a term that some companies use, but the idea is that squads are these sort of teams that you put together for specific projects. So if you've got a 2-quarter long project to do a migration, a lot of times they would say, okay, we're going to make a squad around this. The squad is going to be cross-functional. So it's SRE people, it's application people, it might be DBAs. And then at the end of that bounded, project goal, you typically are put onto another squad. So when I've been on squads, they typically run 3 to 4 quarters. So anywhere from like 9 months to a year. And typically they reorganized us basically around developers and data science teams. So we were always kind of being moved from squad to squad. Guilds are meant to be kind of where the expertise for a certain stack resides. So if you've got React engineers, let's say, or front-end engineers, they might make a guild around React, and they might meet once a quarter, or probably multiple times a quarter on a semi-regular basis to maintain the standards, to make sure that they're all doing the same thing in terms of naming conventions and practices, etc. So that's a little bit on the common organization schemes. Obviously, SRE work is really big on testing. So performance testing is one type of testing that we're going to be doing a lot. Kind of goes without saying. Resilience testing is an interesting, and I think still somewhat emerging area, because resilience testing basically looks to follow the whole application development paradigm of fault injection. So when you're doing application development, you do fault injection to basically make sure that your code is good by injecting faults and seeing how the code reacts. Resilience testing is doing that same thing, but for a system. So there's a tool, for example, called Chaos Monkey that was famously made by, I think by Amazon, where it basically randomly terminates nodes on your backend in order to see how it performs. Obviously, you don't want to do this on production the first time. You do this on dev, then staging, then UAT, and then ultimately production, to make sure that you have enough resilience that if a node goes down, you're not going to have to worry about orders being lost. So it's that whole fault injection paradigm. So that's SRE in a nutshell. Now moving on to cloud engineering, that's what I currently do. So cloud engineering tends, in my experience, to be a broader job function. In my experience, it's used by bigger companies. So enterprise companies, companies that are more than like 500 people, let's say, in size. And it's often kind of a catch-all. And paradoxically, oftentimes cloud engineering involves interfacing with on-premise resources as well. Because a lot of times what happens is the companies will have these data centers and co-location centers, and they're trying to migrate from them to the cloud. And so as a cloud engineer, you have to actually do a lot of the architecture around what that's going to look like, the planning around what, how to do the migration, et cetera, et cetera. It's pretty diverse in terms of job functions. So you end up doing, or I've ended up doing more networking, more kind of one-off weird debugging type things for people who are just having issues. There's also more of a help desk component. And if I'm to be honest, this is probably my least favorite aspect of cloud engineering, because you end up handling a lot of tickets that come in from people who have just various problems. Like there's a guy who's using a tool, he's a data scientist, this actually happened, and he is using like Jupyter notebooks with another tool, and then there's this SSL error that gets thrown when he runs something from his command line. I have no idea I've never met him, I don't know what he's doing, but I have to kind of jump in and help him through this help desk function. So that part of cloud engineering is definitely not my favorite, but I've found that with cloud engineering, you're usually doing some level of that. And cloud engineering, I think, is a little bit more similar to traditional operations engineering. So you're less kind of embedded into a project team the way you would be as an app developer, and you're more kind of doing these sort of high-level catch-all things. So it's similar to SRE, but kind of with an added emphasis. Oh, sorry. This is the next one, infrastructure engineering. So infrastructure engineering is another kind of DevOps adjacent role. It's basically SRE, but with more of an emphasis on infrastructure as code is kind of how I would describe it ultimately. And it tends to shade into platform engineering in my experience. And platform engineering tends to shade into data engineering. So as an infrastructure engineer, I actually worked a fair amount with data scientists, which was pretty fun because you're really architecting the kind of data store, the backend, Redshift data warehouses. You're creating the pipelines that they use to run their models, which then pushes to these places. So it tends to, I think, be more data science adjacent, in my experience at least. And then QA, automation engineering, gets an honorable mention because, again, a lot of what you're doing is going to be testing related, and automation engineering obviously does a lot of testing. So now moving on to modern DevOps principles and practices. So these words I'm sure you guys are all familiar with. So CI/CD, continuous integration, infrastructure as code, which I've already referenced, but that's basically the idea that you want all of your infrastructure to be defined in some sort of code tool. So CloudFormation, Terraform, CDK, something that's basically invocable through code. Observability is key. That's usually by way of either Datadog or Prometheus and Grafana or New Relic or some sort of observability stack that you have. Orchestration, this is how you run your services, obviously. So Docker containers basically being managed for you, and then networking. And I throw networking on here because I think that that's kind of a newer emerging responsibility in DevOps. I think network engineering used to be left more to the network engineers, but now AWS has come out with things like their what's it called? It's on the tip of my tongue. Basically something that allows you to merge multiple networks into a mesh and kind of run all your VPCs through these centralized networking constructs. So this is actually moving more into the DevOps space and away from the traditional networking space, which is something that's I found interesting. Secrets management falls under this category as well. And documentation. So in terms of CI/CD, these are some of the tools that I've used most. Jenkins is obviously the tried and true kind of battle warrior. It's the easiest to get into. It's probably the easiest to run and maintain, and it's probably got the richest ecosystem in terms of plugins and in terms of Stack Overflow posts and in terms of just resources out there to help you run it. GitHub Actions and GitLab CI/CD are both pretty much the same thing, but from GitHub and GitLab respectively. And it's basically a way to define the CI/CD jobs in YAML code, and then it's executed basically in an event-driven kind of paradigm. So when you push a branch, when you merge a branch, or when a branch test succeeds, then it'll trigger all these other things. And Circle CI, I actually haven't worked with, but as I understand, it's pretty similar in the sense that it's YAML in the form of like deployment code. So this is like an example GitHub action. It's ci.yaml. This is obviously a really basic one. This isn't going to do much for you, but here's the name at the top. This is the on. So this is what basically triggers it. So on push or on pull or on whatever action, that's what's going to trigger it. Workflow dispatch is if you want to be able to manually trigger the workflow. So if you want to be able to go in and execute it like a traditional CI/CD tool, then you want workflow dispatch. And then you can define the pull requests that you want it to run on in the branches that you want it to push or that you want it to run in response to, and then the permissions, etc. I'm sure you guys have probably used similar tools in the past. And in terms of infrastructure as code, some of the big ones that I've used are Terraform, CloudFormation, and Serverless Framework. So Terraform and CloudFormation are really competing tools. The difference being CloudFormation is AWS specific, Terraform is cloud agnostic. I tend to lean towards Terraform. I think that's where the industry is moving, especially if you have a multi-cloud kind of setup. And also Terraform it uses HashiCorp configuration language, HCL, which is part of the HashiCorp ecosystem. And HashiCorp is this corporation that basically makes a lot of cloud native type of tools and resources. So they've got like a secrets management tool, they've got a service discovery tool, they have an infrastructure as code tool. The cool thing is HCL basically runs across all those different tools. So I'm obviously biased in favor of Terraform. Serverless Framework is really useful if you're doing any sort of serverless infrastructure as code development. So it's YAML based as well. And it's nice because it'll create a lot of the small annoying connectors. So like, and I'll show you an example later, but let's say you're trying to create a Lambda function, but you want the Lambda function to trigger in response to something that happens, and you want it to only trigger when certain people call it. So this serverless framework will basically make all of those things for you, and it's declarative. So you just say, make this Lambda function call on this condition, and it'll do it for you. That saves a lot of toil. Again, reducing toil is the mantra here. And CDK gets honorable mention too. CDK is Cloud Development Kit, I think is what it stands for. So AWS created this, and it's basically a way to use any sort of modern language to define infrastructure. So if you don't want to use YAML or you don't want to use HCL, you can actually write it in Python, or write it in Go, or write it in Node, and then it'll actually create the code for you. I would say that CDK it's powerful and it appeals to developers a lot, but in terms of long-term maintainability, it's not declarative. It's more imperative. So you're going to have to actually tell it what to do. And in that sense, it tends to take more cognitive effort to make changes. So take that for what it's worth. But I would definitely highly recommend Terraform in the space. And then configuration management. So some of the things I've used, the main one I've used is Chef, which is of course a competitor to Ansible or any other number of config management tools. And Makefiles I found to be a really clean way to kind of abstract the way that a lot of these things are invoked. So since it's 1:40, I'm going to go ahead and pivot to show you some of the code examples that I have had on tap here. So bear with me for a quick second here. All right. All right, so let's start off with, let's see, it's saved quite in the format that I thought, but that should be fine. Like these are some of the things that I've worked on in the past, some of the projects. Let's see, I think this one should have it. So one common pattern that we've had a lot of success with in my companies is, in the same way that in the microservices world you model around a business domain, it's useful to also model your infrastructure as code around business domains. So meaning if you've got different features, what we did is we actually created infrastructure subfolders to live alongside those features. So instead of having just all the infrastructure as code live in its own repository, it's in a place where it's adjacent to the actual code that runs in the application. So let's say you've got this sitemaps generator right here. So that's, it's running, I think this is running a Go service, but it's got its own infrastructure folder here, right alongside the code. And if you go into this is where the Terraform is. And the Terraform you invoke basically on the command line. I was going to do it and show you some invocations, but I don't know if I've got a command line here. I have a Mac, so I don't know if, I don't think this is, and it doesn't have Terraform on the machine, so it's not going to work, but I'll show you the code. The way we often divide our code is we use a common pattern where we have an environments folder. That environments folder has the environment for production staging and sandbox. And you can click into each one of these, and then each one of these is going to have the actual the actual settings. Let's we'll have to go with Notepad. No syntax highlighting for us. So it's going to have the actual settings that you're going to pass up to the parent module. And let me reopen this again. So this line is the key line here. So this source is referencing two directory spots above it, obviously, which is going to map back to this main. This main is kind of the runner that runs, that can be invoked to run production, staging, or sandbox. And then this in turn maps to another module, which lives in kind of an infrastructure directory. So we kind of have this contract with the developers, where the developers, we set up their initial infrastructure as code in these files. Then we also maintain kind of a mothership repository, which this is invoking. So whenever they want to make a Lambda function or create a Lambda function, they're actually not defining the vanilla Terraform Lambda code. They're just invoking the interface or using the interface that we gave them, feeding in whatever variables are required, and then calling another directory elsewhere. So that's kind of the pattern that we've been using, and we found a lot of success with that. So I had mentioned a makefile. So makefiles, I'm sure you guys have used makefiles if you write C code or if you use like the GCC compiler. But basically, makefiles are a way to call targets, which then just run things. So basically, instead of doing Terraform apply, which is the vanilla Terraform way of doing it, we put everything into these targets. So we've got a target for like format. This is the Terraform format target. This is the Terraform validate format. This is the where are we creating it? Terraform destroy target, Terraform apply target. So basically, we use these makefiles for Terraform. We use it for serverless framework. We use it for CDK. We really use it for everything. So all the commands are always consistent in terms of the way that you generate the code. And we found that that gives us a very stable invocation pattern in terms of how the developers create the code. And this is really useful because if you're ever in an application, all you need to do is env equals sandbox make apply, env equals prod make destroy. It's always the same format, regardless of what technology is actually doing the invocation. And that's very useful if you have to jump in and do ad hoc debugging or figure out what's going on. So we've really, really liked this because if you just make everything into bash scripts, your life is going to be really hard when the last person before you had a different naming convention, they use snake case, you use kebab case, they're creating random naming titles. This is really, I think, helps reduce the toil. Again, that's the mantra that you're going to hear over and over again. Let me show you some serverless framework stuff that we've worked on. I think that lives in server functions. It's not here. I'll see if I can find it before the end. Basically, it's just another YAML configuration. But like I said, serverless framework, it creates a lot of the things that you're after automatically. Actually, I think I know where it might be. Let's go back to this guy. No, actually, I don't know where it is. I'll show you some Chef stuff as well. So Chef, when we used Chef, we actually used a version of Chef called Chef 0, which has its pros and its cons. So typically Chef is, it's a configuration management tool, and all of the nodes report to this central server, and the server basically keeps all of the children nodes in sync and in compliance with the stated infrastructure. We use Chef 0, which is kind of independently invocable. So there's no master node that's keeping everything up, which means it's easier to set up. But the downside is you have to deal with Ruby gem updates. Whenever a Ruby gem would basically got updated, we'd have to deal with these cascading failures because of dependencies that were no longer valid or that were no longer there. So Chef was hit or miss in my experience. So I'm going to pivot back to some slides here. So we've got about another 15 minutes. So I've already gone over ad nauseum, I think at this point. Infrastructure as code, make files. Backstage is a tool that I would highly recommend if you're at a company that needs some sort of essentially resource catalog. So Backstage is open source. It's actually created by Spotify. It was a tool that they created in-house and then open sourced and released on GitHub. And it's basically a way to keep track of all of the different resources and assets in a system. And it's flexible enough that you can define what specific resources and assets you have, whether that be JPEGs for the website, or an entire code base, or a service, or a Lambda function. You define what those assets are, and then you basically create another YAML file associated with it. And in the same way that we saw before, the YAML file lives alongside that service in the code base. And you configure Backstage to say, in this repo, look for this YAML in all the services. And it'll automatically aggregate it into this sort of dashboard. And this dashboard is really cool because you can slice and dice it. This one is obviously just an image, but if it was real, you could click into it. When you click into it, you can see this is linked to all of the other assets in such and such a way. Backstage is pretty neat for that. Observability. So in terms of observability, I'd say Datadog has probably been the runaway winner in my experience. Well, maybe neck and neck with New Relic. So those are obviously the two big paid solutions. Prometheus and Grafana is essentially a free version of that. So Prometheus, and I'll have a diagram next, is basically a way it's a system that aggregates metrics, logs, and traces. And then Grafana basically puts that into a viewable dashboard and allows you to query and dice and slice based on whatever query parameters you have. And then there's custom logging solutions that we've used, like in the past, one fun project we had to work on was where we had a cam feed coming in from these various locations, and the camera feed would become degraded over time. And when we would stream it to the website, the customers would call in and say, hey, the camera feed is really bad. And we had to find a way essentially to know when the camera feed was being degraded. So we considered using something like OCR, like just image recognition, to see when it was degraded, but there's a lot of resource overhead with that, and then you need like a system that's actually looking at an actual screen. So what we did was we enabled advanced querying on the streaming technology, which was Wowza. It's like a streaming resource, basically. And then we sent those logs to S3 in AWS, and S3 allows you to use Athena, which is basically a way that you can define a schema, and that schema that you create will parse the logs based on that schema and allow you to query it using the Presto database engine. So you can essentially create SQL databases where you're querying raw log data if you feed it the schema. And that's tremendously helpful if you've got various types of logging formats that you have to deal with. The only downside is you have to define that schema, obviously. This is the promised Grafana and Prometheus diagram. So Prometheus is at the heart of it here. It's essentially the binary that's doing the collecting, and it can either pull metrics, which it calls scraping from various targets that you define, or various targets can push to Prometheus. So it has both a push and pull model capability. Then you've got the primary storage here, and Grafana is the component they use to view it. And so that's how that goes. I already told you about the custom logging solution. Streaming is another emerging area. So I've only really worked with streaming in the context of working with data science teams, because streaming is obviously huge in data science, in the data science world. But I will say that companies are increasingly turning to streaming as it relates to microservices. So with microservices, the challenge is always that you want an event-driven ecosystem, right? Where one thing happens, and then based on that one thing, you trigger something else, but you don't want to make the calls directly because then you're coupling services the same way that you did in a monolith. So streaming is a way, among other things, to get around that, where you've got a service, the service has this kind of like a pub submodel, it emits an event after something happens, that event goes into a stream, that stream is then listened to by whoever wants to know what's going on, and then other things can act upon that stream. And that's a way where you can decouple services, but still have them communicate with one another. Orchestration, I'm sure you guys are familiar with Kubernetes and ECS. Airflow is another orchestration tool that we use more in the data science world for orchestrating kind of more arbitrary workflows. Documentation is also huge. We used PlantUML, which is an interesting tool. So PlantUML gives you a format that you can basically use to define diagrams. So it's like if you go to draw.io or you go to Microsoft Visio or whatever, you can make a server, that server can call other servers, and you can just define endpoints using arrows in a visual kind of what you see is what you get type of system. So PlantUML allows you to define all of that in code. It kind of looks like YAML, but basically based on the way that you order the elements, it'll generate the code for you. And that way it's very easy to just cut and paste 10 lines at a time and move it, as opposed to having to manually move and delete 10 different boxes and arrows and all that, because nobody wants to spend their afternoon doing that. I think I was already at 155. All right, I'm going to show you a little bit more code if I can before I go. So one format or one pattern that we really liked was defining the infrastructure code or defining the monitoring code in the actual infrastructure code. So I think we may have done it here. Yeah, so this is like when we were creating the infrastructure for the application, we eventually made it so that when developers would bootstrap their new application, they would automatically create alerting, like a baseline level of alerting along with it, using the New Relic, in this case, data provider that Terraform exposes. So this New Relic NRQL alert condition. So NRQL is New Relic query language. And this basically is a way to define a query. This is the query. Select the sum of errors from serverless sample, provider like Lambda function. And so this goes, and then this is the evaluation offset. This is the threshold in effect. And so all of this is being bootstrapped alongside the development code, the application code from the very get-go. And that way, there's really no excuse for not monitoring services, because it's really all being created as soon as the infrastructure is created. So that's a really powerful pattern we used. I'm trying to think of maybe one more nugget I can leave you guys with before I go. Oh, here's one of the serverless.yaml files that I was talking about. So yeah, this is serverless framework, and it's really cool because you can, so in AWS, you of course use identity and access management to manage all of the roles and policies. So you can create whatever roles and policies you need right here. You can use plugins to augment functionality. And in this case, this is the function, which is calling this Lambda handler. And the Lambda code is actually going to live next to it in that folder. And so everything that you need for that serverless workflow is being created here. And that just saves a lot of time and a lot of debugging effort of going through AWS and creating an SNS topic and adding people to the topic and creating, all the triggers that you need. This is a way to do it all in code. Super clean. You call it once, it creates everything, and it'll also destroy everything for you all at once. Highly recommend if you ever have to do any sort of serverless deployments. So I think that mostly brings us to time. I got through most of what I was trying to go through. So you were right, Professor. Looks like I did end up exceeding the time. What? Okay, cool. So one interesting thing that I would call your attention to is in terms of evolutionary architecture. So the term fitness functions has kind of historically been used with application code. So creating functions that determine the fitness of what was produced. But in our architecture space, in the DevOps space, people are actually trying to essentially quantify a way to kind of measure the adherence of an architecture with what the architect had envisioned. And so it's kind of abstract and kind of high level, but the idea is we want architects to be able to still design an architecture, but we still want to push out decision-making power to the developers. So we want to give the developers maximum freedom while still maintaining, a sane architecture and making sure that the architecture adheres to all the standards. And so these fitness functions are a way to objectively measure that. So I haven't used this in the actual fields, but I want to. This particular one is an example of somebody who's using a fitness function to detect how many times somebody is like SSH into a server. The idea being that in this particular hypothetical example, I'll just run through it. There's somebody there who's trying to make sure that the operations team isn't manually logging into servers and making changes to the servers. So this is a function, like a query they can use to feed into a fitness function that will kind of give them metrics on how frequently that's happening. Then they can use that and correlate that with outcomes. So if this number goes down and the number of issues in the month went down, then you know that they're adhering to the architectural pattern, which in this case would be using like a jump server or another tool instead of SSHing directly. Kind of high level, but I thought that was interesting and worth the call out. Also, it's worth noting that a lot of the same lessons that have been taken away from microservices are also being used kind of in the architectural space. So I already talked about modeling around a business domain, where we're modeling our infrastructure code around bounded contexts of business domains. So if there's a service that does a thing, we want the code for the infrastructure to also live with the service that does a thing. Culture of automation, we've talked about that. Hiding implementation details. So we were pretty big on this in that architecture I showed you, where we allowed the developers to create their own, or to call the Terraform code that we created in that other repo. And that way we hid the implementation details. So whenever they were creating Lambdas, they weren't changing the approved way to do the Lambda, obviously. And there's also just some useful patterns you can use to increase your resilience. And that I think helps with, again, taking the learnings from microservices and using that more in the networking kind of architectural space, where you can do bulkheading to basically isolate the thread pools that are being used to call various services, so that you don't have a single thread pool that's in charge of multiple downstream services and that gets exhausted and then that kills otherwise healthy services. So it's another resilience pattern. So I think I'll call it there. I think that's the meat of what I wanted to go over. And I'm a little bit over time, but does anyone have any questions?
Do you enjoy what you do?
I do enjoy what I do. I don't know how much that comes out, because sometimes I don't, but usually I do. Awesome. Thank you, guys.
Question?
Oh, sure.
Does the industry pay the cloud engineer well?
Do they pay well?
The industry pay cloud engineers well, because we are all professional. We are looking for a better job.
Yeah. I'd say job perspectives have been incredibly bountiful. So I'm constantly getting, inundated by recruiters who are trying to call and say, hey, we have this opening, we have this position. So very, very strong industry right now.
How about the pay scale? Roughly what's the range?
Yeah, so pay scale for cloud engineering, I think it said on Glassdoor that it starts around base is 75K, but that's base pay and that's nationally. So that's not California, that's countrywide. I think for site reliability engineering, it said it was like 80 base and about 114 average for cloud engineering. And I think it's like 120 average for SREs. So pretty good.
Okay, thank you very much.
Yeah.
Do you also hire?
Is Beckman hiring? Not right now, but if we ever are, feel free to send in your resumes.
Right. Okay, back to our session. Dr. Chen is going to teach 542 this semester, so he's going to introduce this class.
Okay. So I have 15 minutes, right?
Yes, 15
Okay.
minutes.
All right, I'll try to be short.
A little bit more flexible.
Okay. All right. Dr. Drew is always kind to me. Sometimes I can extend the number of times during my section. But anyway, my name is Ning Chen. So some of you probably had my class already in the summer. All right, so we're going to continue that one. So let me briefly introduce this 542 verification validation. I have several former students from that class sitting there. Okay. But anyway, welcome. All right. Okay. But anyway, so the first thing is the logistics. Make sure that everybody knows where to go, how to do things, so that and everybody would be happy, that kind of thing. So the first thing is to make sure that you can access the Canvas website. You can log into the class website. It turns out that we have two sections of section 50, 51, and as before, I'm pretty sure you guys probably went through this already. But anyway, if you are in section 51, I kind of already assign you to the section 50. So you should be able to somehow log into the section 50. But anyway, so if you somehow cannot find section 50, please email me via the Canvas email. That is much easier. So over here, so let me kind of show you the section 50 somewhere. There are so many courses I taught before or currently. Let me see. That's 423, 542, section 50. And you log in, and then you can see this so-called instructor screen. And for you guys, you will see the student view. So that pretty much is the first page you will see for this class. All right. Okay. And then, by the way, the class name is, course name is verification and validation. It's a long name, V&V, right? My interpretation of this class is, it's a fancy name for software testing. Okay. But anyway, so obviously, as I mentioned before, don't have time to tell all the detail about this class. Well, don't worry about that. We do have 15, 16 weeks to go through that. Over here, I just want to mention that first of all is try to find the syllabus. You can see that we have a syllabus somewhere. It turns out it's this one. Okay, if you open it up, then you can see that we do have a syllabus there. All right, and sure enough, you will get all the information you need pretty much right from there. And this syllabus is tentative as yesterday. I may need to revise that one to fix some of the day problems later on. Suppose if I encounter that kind of situation. But anyway, so I may revise that one about a week from now. But anyway, so at that time, I probably ask you guys to download the updated version of the syllabus. All right, but anyway, we have all the information over there about the textbook, about the, this assignment, that kind of thing, about the purpose of this class, blah, blah, blah. And then in terms of textbook, I kind of select two. One of them is mine. Okay, and the reason for that one is over the years I developed some of my passion in software testing, and I kind of decide, well, maybe I should put my views on something. Okay, but anyway, I do have another one. It's a regular textbook there. In this class this semester, I pretty much followed my thinking process over there. Hopefully, you at least try to provide some kind of opportunity for me so that I can show you guys my view in this particular field. But anyway, so that's the textbook. You may ask the question, where do you get mine? Well, it turns out that I post that on the class website. It's free. You don't have to pay anything. The other one is optional. If you want to get it, you need to buy it. Okay. But anyway, after that one, we have this schedule. I think that's my style. I want to lay out everything on the first day of the class, all the 15 weeks of the plan, so that everyone is somehow is aware of the situation, and that gives everybody a chance to have lead time to plan things ahead. I think that's good for you and good for me. All right, so I already post all the assignments deadline, all the requirements, something like that. On the first day of the class, I'm pretty sure that as a professional, you guys are super busy. All right, I'm super busy. Also, maybe that's the way to go. All right, but anyway, so please pay attention to all the deadlines posted over there, and then with the exact day and time, simply because that I kind of plan ahead, and I think that you guys need to plan ahead also, right? I think that's a good career practice. Everybody procrastinates, okay, including me, right? I read that one. So this is my way of forcing myself. Oh, I need to do that because I said so already in front of everyone. All right, if I do not do that, I probably will lose face. That's my way of forcing myself, okay? I hope that you find your way to force yourself. But anyway, because of this predetermined deadline, I typically do not accept late submission. Sure enough, if you have some valid reason, well, you know, my wife, I don't know, some kind of argument with me and so stressful, blah, blah, blah. Yes, I accept that. Okay, no problem. I need to travel because the company gives me the last minute, travel request, that kind of thing. Yes, I'm negotiable, but please keep in touch and let me know beforehand instead of a last minute or after the fact. Okay. All right, but anyway, so that's roughly 15 weeks of the 17 weeks actually, including the final weeks. All right, but anyway, and then the grading policies is right there. We do have a group project, and one of the emphasis of this program is to encourage group working, simply because I have some kind of a view on this industry. I kind of describe the software industry as people business. Software business is a people business nowadays. Okay, why? Because you have people skill, you pretty much can make a much bigger money. Okay, it's not just a technical business anymore. But anyway, so that's one of the reasons we have this group project building, so that you can say, well, you know, we meet together. What happened to your company? Or is your company looking for another, position, that kind of thing? This networking opportunity is part of the MSE, all right? So that's one reason why we have this group project. I guess that occurs in all the MSE class courses. Anyway, if you worry about your grade, by the way, that shouldn't be a worry because basically a lot of a portion of grades is effort based. If you put in the effort, you should be okay. All right. And then about the group project later on, I will kind of, if you have time, remaining time, I will say more about that group project. But it turns out that we do have an essay assignment. We do have the individual presentation in addition to the group project and group project presentation. And also, as I mentioned, all those assignments are discussion assignment. Basically, you can find all the assignments, discussion assignments in this syllabus already, and also the grading rubric for all the assignments. All right. So pretty much everything is on this syllabus already. If you have any doubt, you simply go to the syllabus, then you should be okay. All right. I also practice one of the software engineering best practices, I guess. This is called single source information. All right. You don't want to somehow assign value to some kind of constant variable everywhere in your program. Only one place that you have that x equal to 10, right? If you want to change that one, don't reassign x to 11 in some other place of the program, your program. Then you create some kind of a bug over there, potential bugs right there, all right? So same thing over here. In the rest of the class material, I always say that, well, go to the syllabus and then you'll find the information over there. It's a single source of information, right? But anyway, you guys are smart. I just want to mention that, hey, we want to practice what we preach, right? So in this very small principle of single source of information, I want to do that in this class also. All right. I guess pretty much that's 10 minutes already, right? I have 5 more minutes to go. Can I have that? Okay. All right. So I guess that pretty much resolves this logistic issue. Any question regarding the logistic of the class? Logging and then, worry about your grade, assignment, due date, that kind of thing. Okay, very good. All right. The next topic is I just want to talk about a general idea of the software testing or V, verification and validation. All right. I think that although we are academic, unit over here, but on the other hand, we are professional. Most of us is responsible for bringing enough bread back to your family table, okay, so that people can enjoy. All right. So career planning is also quite important. So from this point of view, sometimes we want to ask a question: what do I get from this class? Okay. Well, this class enhances my marketable skills so that people pay me. Okay. All right. To answer that question, I would say maybe you need to follow the money flow. Okay. Based on some statistics, yes, not a single answer there. But in general, I kind of believe that some researchers claim that over 50 cents of the overall money spent in $1, eventually the 50 cents goes to software testing. Okay, so if that is correct, some people claim only 30%, 30 cents instead of 50 cents. But anyway, obviously it's a bigger amount. All right. If you follow the money flow, then you say, well, this class actually probably is worthwhile to, at least spend more time. Okay, simply because there's a good portion of money somehow goes through that channel, so to speak. All right. So that's the first thing I want to mention. All right. The second thing is, then you say, well, okay, it seems to me that there are money to be made in this particular channel or industry or field. Then how do I make it? Okay. And then before anyone can answer that question, I kind of suggest that, hey, you look at this particular business field and try to figure out who are the mover and shakers in this industry, in this particular field, and figure out what they are doing, okay? Because they are the winners, right? So another way is, well, if you want to become one of the winners, so you need to know who are the winners, right? Okay, so basically my view on this is there are three basic winners or mover and shakers in this industry. One is academic, like people like us. We kind of try to come up with a new idea, hey, and claim, hey, this is a innovation, blah, blah, blah. So one group of people who drives this kind of thing is from academia, okay? The second group, I would say that is kind of combination of people in industry and, they have a strong academic background, although they are not professors, but they actually, most of them are earned their PhDs, anyway, so they are interested in claiming that innovation anyway. So those people come up with standards. Oh, there's a lot of standards, okay. IEEE standard, the TMMI standard, why? Well, they become the rule maker, the king. But anyway, so that's another group of people. And then the third one will be practitioners, right? Most of us, or most of you probably eventually falls into, at least initially, that become a practitioner. We are the down-to-earth soldiers, so to speak, or worker to do the work, okay? We face this daily issue of some kind of situation, and we need to find a solution to fix that one, all right? And then over time, obviously, we come up with some kind of idea. Those are the practitioners, okay? So in this class, I hope that I can kind of bring those three group of people's views into some kind of mixture, so that you got a balanced, observation from those three. Maybe you can come up with your own observation, own knowledge, or own innovation also. But anyway, so that's the reason why in this class, we'll look at those academic, this theory type of things. We'll also look at a lot of standards, all right, or best practices, some kind of model, that kind of thing. Eventually, we'll also look at the whatever things it came out with those practitioners. Nowadays, we have open source project a lot. It turns out that for this class, the open source project, the group project, I will use the realistic open source project. It's called Odoo. Okay, Odoo is an ERP system. It's not the #1, but it is within top 10 already. And the reason I select that, one of the reasons I select that one is because it's open source. They don't have any secret to hide from you. And then they have source code for anything, for testing, for development. And also the technology they use is well-established, mature technology. And we see that kind of thing. The MSE is not fancy, has been around maybe 20 years. But it's a bread and butter of the industry, okay? For those of you who are not that familiar with that one, or just kind of enter the industry, you want to pursue butter and bread first, instead of this fancy cake, simply because the butter and bread has some kind of long-lasting value. It's not like a fashion show comes and goes. You probably noticed that some of the things that comes and goes, all right? Long-term investment may not be a good choice, all right? So Odoo is a mature technology, all right? It's a Python-based, a lot of people enjoy Python. The front end is the JavaScript. It's not the React. However, based on the Odoo's own document, they claim that one, their front end is a mini React, all right? they follow the React idea and use ideas over there. I look at their front-end source code, it's only 2,500 lines. Then look at that one and say, oh, okay. Is it within my ability, so to speak? If things come to worse, I can look through that 2,500 line and figure out what's going on. All right. So it's not a huge one. All right. If 25,000, forget it. I cannot make it. All right. But anyway, so that's from it. I think that would be a good choice. It's a balanced choice. All right. Although it is a group project, and I encourage you to kind of spend your time. But for some of you, maybe it's a little bit challenging. Okay, I personally actually spent more than a couple hundred hours on that one already. Sometimes it's quite frustrating. Okay, but on the other hand, as far as the group's requirement is concerned, I'm not that picky. Okay, if you guys show your effort, that's fine. All right. But I do encourage you, if you somehow feel that that fits your career, you may want to kind of, push a little bit in and then invest a little bit more of your time. Okay. And for me, I kind of want to invest my time there because I look at that as a long-term, it does have a potential long-term return for me. All right. But anyway, I just want to open out that as a opportunity for you to see whether you like it or not. All right, that pretty much is my presentation. I hope that should be okay. All right, thank you very much. Really appreciate your patience.
Be short, and since Dr. Chen already covered some of the infrastructure support, you probably already know, so I don't have to cover. I don't have to repeat. And also, I think we all work together spring, the semester before. So, this is not totally new. Okay, so I'll try to be short. And also before I start, I think the speaker talked about that. James Kim, he actually has some relation with the MSE. So about 20 some years ago, he actually contacted us. So he wants to come here to give a talk. At the time, he is promoting a cyber security and also you're the product. Since we, MSC, we also highlight Zero Line. And so, he wants to see if that we can integrate some of his work in our, actually in here and also give a talk. And after 10 years, now he became a guru in DevOps. So you never know. If you Google him, you don't see cybersecurity stuff anymore. Okay, I'm going to be try to be relatively short. So you already know a lot of stuff regarding MSE, how it works, and basically two key terms to do well. One is discipline, one is good planning, okay, because you all have to handle, balance a few different things. Okay, that's fine. And for measurement, this is kind of a unique class. Most of the software engineering class curriculum, they don't have a subject like this. And this is kind of important. In the previous talk, we talked about DevOps, and also one component is measurement. How do you know it worked? How do you get feedback? How do you make adjustment? All that stuff. And so since about 15 years ago, I've been getting into this cycle, try to lose weight every 2 years. Okay, I lost some weight, I gained them back. When I try to lose weight, I need a scale, right? So pretty much I weigh every day. Okay, now imagine, see what's the value of metrics? It's like you imagine you try to lose weight. Okay, now the scale. I have the scale. Does not mean I'm going to lose weight, right? But if I want to lose weight, scale going to help, right? So if I try something that work, right? Or if I try something that did not work, so I need to know, I need to get the feedback. So this is basically the value of metrics. Okay. The textbook is relatively old book. okay, measuring software process, statistical process control for software process improvement. The reason we still use this book is this is probably the only book talk about SPC in software. Okay, so the statistical thinking, process thinking is I think is very, very important for people doing software. So we still use this book. The highlight of the book is chapter 4, chapter 5, chapter 6. Okay, so those three chapters basically cover SPC in software. A few other books, I'm going to just mention two. John Doerr, so some of you probably know him. He's a guy invested in Google. He's a guy who developed popularized the OKR, the scheme. Now he wrote a book, Measure What Matters. That actually is a bestseller. Imagine a book on measurement. Okay, it's a bestseller. So probably can look at this. Another book is How to Measure Anything. This is also an outstanding book. And both of them have a lot of story. Okay, so give you some idea and also make it easier to read. The classwork, I already post everything online. So you probably can take a look. I just want to highlight a few things. Discussion board is kind of important. Dr. Chen mentioned the effort grade. That's an effort grade. Okay, so and also we have a lot of experienced students. Okay, so sometimes it's not only we learn from each other, from instructor. You also learn from your fellow students. So we have a lot of students, a lot of experience working in industry, and so it's a good place. They can share lessons learned, experience, and there will be some assignment, and also there will be some term project. So this is the typical grading policy, and here are some of the objectives, and I already posted, so you probably can take a look. One thing I would like to, I guess, highlight is maybe even though the book is old, and we try to integrate some of the new development into the class. So we'll post a lot of other, different blogs and some of the new articles. Okay, and also maybe some of the new books. Okay, and here are some of the topic I'm going to cover. Again, you're going to read the detail through the syllabus. So I'm not going to repeat week by week plan. Okay. This one is about some of the possible project topics. Okay, so the idea is kind of, you could have a team, right? And find one thing and go deep. Okay? And, try to learning by doing. Okay? And try to maybe see how to apply some of the lessons learned, best practice in industry, get into something more specific. So there are some of the old topic, some of the new topic. And and also obviously you are not limited to this as the practice we did before. So what happened is, you form a team and send me abstract, give me the objective and the scope of work and some sort of plan, then I'll give you my feedback. So we pretty much basically reach some sort of agreement. So you understand what need to be done. And here are some of the important dates. Okay, so you should be able to find all that in the syllabus. Okay, I think that's it. Any question? There's a storm coming, right?
That's really fast. Okay. Do you have any question for Dr. Cong?
How many members?
We typically have like a 5. If exceptional case, we just email me. So I know you're probably going to have the same team, or if you can have a different one, that's also fine. Okay.
Okay. Do you have any question to me? No? All right. Thank you.